Welcome back to the deep dive. Today, we are getting into something that I think everyone listening has dealt with probably this week.
Oh, for sure.
It's that universal tension in the modern workplace. You know, it's the eternal battle between the IT department, who essentially want to lock everything down in a concrete bunker
Yeah.
at the bottom of the ocean.
And the actual employees who are just, desperately trying to get their work done without filling out a form in triplicate every time they need to save a file.
Exactly. It's security versus productivity. And usually, one of them has to lose. But we have a stack of documents today that, well, it claims to offer a truce, specifically for anyone working in the Microsoft Azure cloud. We are decoding a guide titled Secure Your Azure Resources with Azure Role-Based Access Control.
Or, as everyone in the industry calls it, RBAC.
RBAC. It sounds like a nasty cough.
It does a bit.
Yeah.
And honestly, on the surface, it sounds incredibly dry. It sounds like, compliance training. But when you actually peel back the layers of this report, it is a fascinating philosophy. It's essentially a constitution for your digital environment. It defines how we organize power and trust.
Organizing power and trust. That makes it sound a lot more Game of Thrones than I expected.
Well, it can be.
So to ground this, our source material introduces us to a fictional but honestly painfully relatable company called First Up Consultants.
Right. First Up Consultants. They are an engineering firm. They do electrical design, circuit design. And like pretty much everyone else, they've moved their assets to the cloud, specifically Azure, so they can collaborate across different offices.
But they have hit a wall. The IT department is sweating bullets. They have these proprietary circuit designs that need to be Fort Knox.
Of course.
But they can't be the bottleneck every time an engineer needs to reboot a server or update a database. If they lock it down too tight, the engineers can't work. If they open it up, they get hacked.
Precisely. And that is the mission of this deep dive. We need to move past the acronym and understand this fine-grained authorization system. We need to figure out how to give people the keys to the car without accidentally giving them the deed to the house.
Okay, let's get into the weeds. The source material starts with a distinction that I think trips a lot of people up. It separates identity from access.
Yes.
In casual conversation, I feel like we use those interchangeably. I need access, I need an ID. But here, they're completely different mechanisms.
They are. And confusing them is where a lot of security holes start. Think of it this way. Identity is about proving you are who you say you are.
Okay.
In the Microsoft world, that is handled by Microsoft Entra ID. You might know it by its old name, Azure AD.
So Entra ID is the bouncer checking my driver's license at the door?
Correct. The bouncer looks at your ID, sees that it's really you, and lets you into the building. That is authentication. That is identity. But once you are inside the club or the office building, where can you go? Can you walk into the CEO's office? Can you open the safe behind the bar?
Hopefully not.
Exactly. That is access. And that is what RBAC controls. It's not about who you are anymore. It's about what you are allowed to touch.
The source makes a really interesting point here about what they call the leaving problem.
Ah, yes.
This is a huge headache for IT, isn't it, when someone quits or gets fired?
This is critical.
Yeah.
In the old days with on-premise systems, you might have to go delete a user from 10 different servers or applications manually. It was a nightmare.
I can imagine.
But because Azure RBAC is tied to that central Entra ID, there is a kill switch.
So if I get walked out of the building and they kill my account locally?
You immediately lose access to the cloud resources.
Yeah.
The signal shoots up to the cloud. The identity is gone, so the access just it evaporates. You don't have to go into every single server and delete Elaine or Sarah. You cut the head, and the body stops moving.
That is convenient. But let's look at the machinery of RBAC itself. The text relies on three main concepts. They call it a magic triangle. The first point of that triangle is the security principle.
Which sounds incredibly formal. The security principle.
It sounds like the person in charge of a high school detention. But in plain English, what are we talking about here?
It's just a fancy umbrella term for the who.
The who.
Who are we giving access to? Obviously, that could be a user like you or me. But, and this is key, it can also be a group. So the marketing team or the engineering team.
Managing groups seems way smarter than managing individuals.
Always.
If I have to add permissions for every new hire one by one, I'm going to lose my mind.
Always.
Yeah.
You never want to assign permissions to a person directly if you can avoid it. You assign it to a group. Then when a new person joins the team, you just drop them in the group and they inherit the access. It's scalable.
But the source mentions a third type of who, and this is the one that confused me a bit. It's not a human, and it's not a group of humans. It's an application.
Yes. This is where the cloud gets interesting. They call it a service principal or a managed identity.
Why does an app need an identity? Are we giving robots driver's licenses now?
Well, think about the alternative. Imagine you have an automated script that runs every night to back up a sensitive database.
Okay.
That script needs permission to read the database and write to the backup storage.
Right.
In the bad old days, a developer might hard-code their own username and password into the script so it could log in.
Which is a terrible idea. That's like leaving your house key taped to the front door.
It's a security nightmare. If that developer leaves the company, the script breaks because their account is disabled. Or worse, if the script is hacked or someone reads the code, the hacker has the developer's credentials.
So the service principle solves this.
Exactly. You give the application its own identity. You give the robot a badge.
Mm-hmm.
It has its own permissions that are totally separate from any human. So if the developer leaves, the robot keeps working. And the robot only has permission to do that one specific job.
So the who isn't just people, it's robots too.
Exactly. You aren't just giving access to people, you are giving access to apps and groups. That's the first leg of the stool, the security principle.
Okay, so we have the who, now we need the what. The source material calls this the role definition.
Right. A role definition is simply a collection of permissions. It's a list of operations that you are allowed to perform: read, write, delete, and so on.
And Microsoft, being helpful, gives us a bunch of built-in roles so we don't have to write these from scratch.
A lot of them.
The source lists 4 fundamental ones. I want to run through these because they act as the archetypes for everything else.
Let's do it.
First, we have the owner.
The owner holds the keys to the kingdom. They have full access to manage all the resources, but the critical distinction, the superpower, is that they can also delegate access to others. They can hire and fire, essentially.
Then we have the contributor. The source says they can create and manage resources, like spinning up a virtual machine or a database, but they cannot grant access to others.
I like to think of the contributor as the ultimate middle management role, or maybe the lead engineer.
Okay.
They can do all the actual work. They can build a house, paint the walls, change the locks even, but they can't give a key to their friend. Only the owner can do that.
That seems like a really important safeguard. You don't want your engineers accidentally opening the door for everyone else.
Exactly. It keeps the circle of trust tight.
Then there's the reader.
Does exactly what it says on the tin. They can view existing resources. They can look, but they cannot touch. They can't restart a server. They can't change a setting.
So for auditors, maybe?
Perfect for auditors.
Right.
Or maybe an executive who just wants to see the dashboard to check the budget, but shouldn't be allowed to touch the buttons.
And the fourth one is a bit niche. The user access administrator.
That's a specific role just for managing user access. It's like the HR department of roles.
Yeah.
They might not be able to touch the servers or see the data, but they manage who gets in the door.
Now, the text mentions there are over 200 built-in roles. But what if I'm special? What if First Up Consultants has a weird requirement that doesn't fit the mold?
Then you can create custom roles. You can mix and match permissions to fit your exact needs. It allows for, JSON-level customization.
This brings us to a part of the source material that I found really nerdy, but actually kind of cool.
I think I know where you're going.
It's how the permissions are actually calculated behind the scenes. It talks about actions and no actions. It feels like a math equation.
It is a math equation. This is the allow model. In Azure RBAC, you don't generally have deny permissions in the standard sense. You are granted permission to do things.
So how does the math work?
Ideally, you define what someone can do. Those are the actions. But sometimes it's easier to say you can do everything except this one thing.
Give me an example.
Take that contributor role we just talked about. If you look at the definition in the source code, the actions is just a wild card, a star symbol. That means do everything.
But we just said they can't grant access.
Exactly. That is where node actions comes in. The definition essentially says actions, everything, but node actions, authorization write and authorization delete.
So the formula is everything minus the ability to give permission.
Precisely. Effective permissions equals actions minus node actions. It's a clever way to build powerful roles without having to list out every single possible tiny action they are allowed to do.
Yeah.
It keeps the role definitions cleaner.
Okay, we've got the who security principle, we've got the what role definition, now we land on the where. This is the scope. And honestly, reading the source, this feels like the place where most people mess up.
Oh, absolutely.
Yeah.
This is the most dangerous part if you get it wrong. Scope is about where this access applies. You have to understand the hierarchy.
The source outlines it like a waterfall. Can you walk us through the levels?
Sure. At the very top, you have the management group. Under that, the subscription. Inside the subscription, you have resource groups.
Right.
And inside those, you have the actual resources, the VMs, the databases, the storage accounts.
And the key concept here is inheritance.
Yes. This is the aha moment. If I give you the owner role at the subscription level, the top level, you are automatically the owner of every resource group and every single resource inside that subscription.
That sounds efficient, but also terrifying.
It's both. It's efficient because you don't have to assign access 50 times. But it's dangerous because of what some people call resource group sprawl.
What do you mean?
Imagine First Up Consultants has a subscription. Inside that subscription, they have the dev project, the test project, and the production financial database.
Okay.
If I make you an owner at the subscription level because I want you to help with the dev project.
I suddenly have the keys to the production financial database, too.
Exactly. And you could accidentally delete it. You wouldn't mean to, but you have the power.
So the lesson here is granularity.
Exactly. The source emphasizes that you can be specific. You can make someone a website contributor for just one specific resource group. They have power there and nowhere else. You water the plant, not the whole garden.
Let's make this real. The source walks us through a scenario with our friends at First Up Consultants. We have a coworker named Elaine.
Right. Elaine.
Elaine needs to manage virtual machines for a project. But we don't want Elaine to have the keys to the entire castle. We just want him to work on his VMs.
So we're going to apply the least privilege principle. We go to the Azure portal and we find the specific resource group he's working in. Let's say it's called Example Group.
We open up a pane called IAM.
Identity and Access Management. That's the control center for all of this.
We click Add Role Assignment. Now, walk us through the selection, because I feel like this is where I'd choke. There are so many options.
It can be overwhelming. First, we pick the role. We search for a virtual machine contributor.
Okay.
And notice, we are picking virtual machine contributor, not generic contributor.
Why does that matter?
Because a generic contributor could also delete the storage account or change the network settings. A virtual machine contributor is restricted to just VM actions. It restricts the what?
Got it. Then we pick the member.
We search for Elaine in the directory. That's the who.
And because we started this process inside the example group resource group, that is our where.
Exactly. We hit assign. Now, Elaine can start, stop, and restart VMs in that specific group. But here's the beauty of it. If he tries to go to the billing tab,
Blocked.
blocked. If he tries to delete the resource group itself, blocked. If he tries to mess with a different project, blocked.
That is satisfying. It protects Elaine from himself, honestly. I'd hate to be the guy who accidentally deleted the production database because I had too much access.
Absolutely. Security isn't just about stopping bad guys. It's about stopping good people from making bad mistakes.
The source also mentions a great way to double-check this, because after a few years, your permissions can get messy. People move teams, projects change.
It's called permission creep.
Right. So there's a My Permissions tab and a Role Assignments tab. You can actually see a list. It will tell you, Elaine has this role because it was inherited from the subscription, or Elaine has this role because it was assigned directly to this resource. It breaks down the waterfall so you can see where the water is coming from.
That's a great way to put it.
Okay, so we've set up the rules. Elaine is happy, he's rebooting his VMs, the IT manager is happy, the billing data is safe. But how do we keep track of this? The source talks about governance and the activity log.
Right. Because in the real world, you need an audit trail. If a permission changes, you need to know who changed it.
The oops log.
Essentially, yes. The activity log in Azure records these control plane events.
The source gives us a little exercise on how to filter this, because if you just open a log, it's going to be thousands of lines of server started, server stopped. It's noise.
Too much noise.
Yeah.
So the guide tells us to filter by operation. You can type in the word role.
And what do we see?
You see specific operations like create role assignment or delete role assignment. You can see exactly who gave Elaine that access and when they did it.
That is crucial for that quarterly review mentioned in the First Up Consultants scenario. They audit this stuff every 3 months.
And you can even download it as a CSV file, so you can put it in a spreadsheet, hand it to the auditor, and prove that you are actually in control of your cloud environment. It turns a chaotic cloud into a compliant one.
It seems like this activity log is the answer to the question, who changed the locks?
Exactly.
Bringing it all together, we've looked at the philosophy, the mechanics, and the checks and balances.
It really comes down to that magic triangle the source describes. To create a role assignment, You need three things.
Okay.
One, the security principle, the who. Two, the role definition, the what. And three, the scope, the where. You combine those three, and you have secure managed access.
It's funny, when we started, I thought RBAC was just about security walls, like keep out signs.
Hmm.
But reading through this, specifically with the Elaine example, it feels more like an enabler.
That is the perfect takeaway. If you don't have RBAC, you have two choices. Either lock everyone out so they can't work, or give everyone the admin password and hope for the best.
Which is a nightmare.
RBAC allows for autonomy. It lets Elaine do his job completely independently within his box without sacrificing governance, meaning the company knows the broader structure is safe. It strikes that balance.
Before we wrap up, I want to leave our listeners with a thought that struck me while we were discussing the node actions math.
Oh.
We spend so much time in our digital lives, and maybe even our personal lives, focused on what we can do. I can access this, I can buy that. But there is something incredibly powerful about explicitly defining the node actions.
That is interesting.
Think about it. How much more secure would we be if we explicitly define the things we absolutely should not be able to do, even if we have the keys? Like, I have access to my savings account, but I have a node action on withdrawing more than X amount without a second approval.
You are applying Azure architectural principles to personal finance. But you are right. Constraints aren't always bad. Constraints are often what allow us to move fast with confidence because we know the guardrails will catch us if we drift.
Exactly. Guardrails allow for speed.
That's it.
Well, that is a wrap on our deep dive into Azure RBAC. Hopefully, next time you request access to a folder and get denied, you won't just be annoyed. You'll appreciate the beautiful action minus node action math happening in the background.
But you'll probably still be a little annoyed.
Probably. Thanks for listening, everyone. We'll see you on the next deep dive.